Hello, welcome back to part 3. I actually recorded it for a while earlier, but I just made a mistake inside Mota and lost all the values, so I'll have to restart. New engine data file, configuration, read valve, no air filter box, and single expansion chamber. This is where I made a mistake. I got 3 different port types. I just left it at 1 and made a mistake clicking exit in a further menu, and I lost it. Basic dimensions: 46 mm stroke 46, a square about 85 cc. I can't remember. No wrist pin offset. Crankcase volume, let's set 250 cc. I'm just putting in values now, just to show you how to build an engine quick and easy. This is the head volume for compression ratio. Let's set this to 6, and connecting rod length as it is 46. Double that is 92. Let's set it to ratio is often 2.2, but let's set it to 100 millimeters. Ignition combustion, I won't alter these values, and right here I just set the flat curve 12 degrees, and this is if I want to simulate in another weather condition from the standard. This is the standard setup that every dyno is compensating from, that has a weather station. Fuel scavenge, this one maximum high performance 0 to, this is set high performance is, I don't know, let's set this to 0.8, and high performance is 1.0 recommended there. Here, high performance 0.7 to 1.0. 1.0 should be the best possible then. Air fuel rate to 12.5, and remember, you need to use point, not comma. Comma makes it not work, the simulator doesn't work. Next screen, run parameters, YouTube 85 cc 001. I'll leave that. I actually do not have a grip on what this is. Somebody can explain to me. And I'll set 40, and the lowest, let's set 4,000, and set 250, and let's watch at 13,000. That's where the graphics output is based on. And inlet read, I got 1 inlet read, lock angle, let's set 25, 30 degrees. Number of ports, 4, this is not a V-force or anything. Port width, let's set 20 millimeters, and length 30 millimeters. Corner radius 2 millimeters, quite sharp corners. Stop plate radius 50, above 50 is infinite, if I remember correctly. So I'll set, there is a stop plate and a radius, let's set 40. And let's open the reads about 30 millimeters. And I want to use carbon, so I need 1370 and single, and 19.5, says that down here. And this needs to be wider than the port width, so let's set 23, 1.5 millimeters around. Unclamped length is a little bit longer than this, of course. So let's set 35 millimeters, and 0.4 is quite good to start with. Transfer, axial, let's set an Aprilia RSO is quite steep upwards, but this isn't such engine, so I'll set like 60 degrees maybe, I don't know, and backwards I should have read the manual, but let's say it's 45 degrees backwards. Start open angle calculator. Let's say you open that, let's say you got 130 in total duration. That would be about 260. Oh, my head calculation. I'll just set 100. 100 times 2 minus 360. That's way too much duration. So let's set 120 times 2. Now we got 120 minus 360. And let's set 124 times 2 minus 360. Oh, that's the wrong direction. 116 times 2 minus 360. 128, that's good enough. Oh, now I forgot. 232. 232 divided into 116. Let's set 116 right here. Full open angle, 180 degrees. Fully open when piston is at the bottom dead center. Profile, no. You can profile the port, but you get a lot more values. But I'll just got 2 of those. No, 1. Arc width, let's say that port is 12 millimeters wide. The top radius that's 2 millimeters and 2 millimeters. This is just a square port. Let's set it 40 millimeters wide. Next, and I'll use the same. This is more upwards in older cylinders than newer ones. So I'll set it to, wait a second, oops, I cannot. Let's say it's a bad cylinder. We can change this later. And 90 degrees towards each other. I think it is that way. And same duration and 180 degrees. No number of ports. 1. The 1 means there is one at one side of the cylinder and one at the other side. Arc width, those are 50 millimeters wide also. I don't know. I'll just set it 2 and 2. Transfer 3, this is boost. Let's 45 degrees upwards and radial 0. I think it is like that. Start open angle. Let's just set at the same. Do it easy for ourselves. 180. No. And this one, you got 1. Only, and let's say just 12 millimeters wide. Top radius 2 millimeters, bottom radius 2 millimeters. Quite square ports. Exhaust, no exhaust valve, and I got a single exhaust. Let's make it very simple. 25 degrees downwards, and let's set 0. And start angle. Let's see, 80.2, that's 200 degrees. That's quite steep. Let's set 90. 90 times 2. minus 360, 190. We got 190 in exhaust duration. So 85 and fully open angle 180. Profile no. Number of ports 1. Unprofiled port width, let's say it's 30 millimeters wide. So, or nah, let's set it to, yeah, 30 would be good. And top radius, this setting small radiuses there will make a quite nasty port for the piston ring. So I'll set the radius 25, like a 50 millimeter circle. And bottom radius, I can set, I'll set the same. Next screen, inlet, make it easy. The bell mouth, yes, it's a velocity stack on the carburetor. Number of sections, I'll do it easy. One can set, you got more values to put in. But I got a 30 millimeter carburetor and it's 90 millimeters long. And the flange at the intake is 30 millimeters. And this in length from flange to petal tip, this I should have calculated, but I'll just put in a value. Let's say it's 55 millimeters. And transfer this values isn't really that important. Nice smooth entry into them and smooth exit. I don't know exactly. This diameter should be larger than the port opening in the cylinder. And let's say it's like a 30 millimeter pipe and length. Let's say the lengths are 45 millimeter long. And I'll do that on the same 30, 35, oops, yes, and this is also 40 millimeters long, and this is the boost, yes, diameter in smaller, and this is also 40 millimeters long. Now expansion chamber. I'll take the other program, Pipe DSN, and start putting in some values. Let's make it a simple one, 2-stage, exhaust temperature manually, and 580 degrees, and exhaust port effect. This is I'm quite uncertain of. I may redo here. I might put in some wrong values, but let's say it's like 35 millimeters flange, and diameter at the barrel flange. Let's set the same. It reminds me what's wrong. And let's say the duct is about 60 millimeters long. I often use that. This is one can make a lot of wrong. So let's just do that and take a value and some. You can look at this. I need to know stuff and I haven't calculated anything, so I'll use this now. Let's set 11. Exhaust port opening. Oops. Smooth entry. Next. I can't go there. I need to 190 degrees. Okay, oh, my mathematics. I've been working today, so my brain is quite tired, but I'll just put in some value now. I can go back here and look at it. And I can do it right now. And that was 60, 35, I said 35. And 4 sections, let's start at 35 and let's say it's 100 millimeter, oops, and 380 millimeters long. This will be a very strange one. No, 75 and 300 and 75, oops, and 100, let's say 90 millimeters, and that one's 100 millimeters long, and 90, this is the belly, 90, and let's say 75. No, I need to rev, so 65, and 90 down to 19 millimeters, and this is, let's see, 300, that's 400, 465, let's set it to 180 millimeters. Have a tailpipe, yes. I'll do it easy. Length, this is the exhaust pipe, so let's say it's about 300 millimeters long, including the silencer. Next screen, yes. Now I'll go back here and check. 85, yes. 85, and I wanted it to make peak power 13,000 RPMs. I don't name it right now. YouTube, and calculate. Barrel flange diameter is less than 1.5 times port effective diameter. Barrel flange is less, so I need to, let's say this is 37 then. Yes. So now I calculated the pipe. I can go back here and put in these values. It's not this will be the base for adjusting later. So I'll take all these measurements. I just put these in because I needed to click next. If one clicks exit the main menu, I would lose all data I've built up. So I'll put the values inside now, and diameter at flange, this 37, I'll put 37, and the length from piston 63, I said there, I said 60 there, I don't know why I put 63, 60, and how many, there is length 1, length 2, length 3, 4, 5, and 6. So I'll set 6 parts right here. So now I got more values. Start at 37. This is 37. And it ends at 71.2. 71.2. And it is, how long is it? Oh, wait a second. This, I mean, length 1. Length 1 is 11.3, and it is the same. 37. Length 1 is 11.3. Now we can 37 up to 71.2. 71.2. Always use point, not comma. And this part is length 2, 292.4. 292.4. Length is on the second part, length 2 is 292.4. 292.4. 292.4. And third part, length 3. Length 3, this is up to diameter 3. Oops, I made a mistake here. 37 up to 71.2. 71.2. Oops, 71.2. And now this 71.2 up to 105.3. 105.3, and this part is 99.8. 99.8, and this is the belly, 105.3 and 105.3, and the belly is length 4, it's 78.4. 78.4, and oh, this is so lazy. 105.3, this is this part, and the diameter out is diameter 25.5, 21.5, 21.5, and the length is length 5, 171.1, 171.5. And the last value, this is 21.5 and 21.5, and the same length here. In Sweden, here is hair, so it's Swedish about hair. However, let's continue. 171.5. Have a tailpipe, yes. Diameter, oops, no. I have done the tailpipe actually right here. So next screen, save the data file. The pipe step factor provided runway is too large and must be reduced in values. So this is why I don't actually know what this is, but this is, let's set 11 here. Now when I've done all the numbers, it changes this. So 11 is maximum right here. So save, and this is my Husqvarna folder, and let's make a YouTube folder. New folder, YouTube 85cc. Let's name it 001, because now I got it in a folder, 001.1. Save, and now let's simulate that pipe. No optimization. Let's run, see what it does. And it's done. Escape. Now we look at the mess I made. Open engine graphical information. There one. Oops, this is not correct. Something's really, really bad here. And well, however, this is the beginning of putting an engine into. This went really wrong. This is probably the reed valve that's major effed. So I need to measure. I haven't gotten it right here at the computer now, so I'll do that later and keep on recording. But I'll go in and make some. I regret that. I'll go in and make some changes. See if it makes some changes when altering the reed. It's often the reed makes that. No. Wait a second. Is it this? Number of ports? 2. Bridged? No. It should be like this. 2. I forgot that. Bridged? No. Save the data file. I'll take the same file name and do it once over again. Exit the main menu, run the simulator. Let's see if it was any changes. It's done. I can close this one. I close that one. And now let's see. Take YouTube. Yeah, it's not good, but it's started to be a curve here. And 4.29 horses. So now I have just from my head built some strange engine. So now I need to go back and correct to a working version of an engine. And however, inside here you can look at some things. I wanted to show you this. This is really wrong. Everything's wrong. But now I've shown you how to build an engine inside here, and I can show you how to look at some, waves, how the expansion and let's say pressure. This is the piston movement, and we can see, let's speed it up some. Piston opens. Oh, it was a very minor wave. So this isn't effective at all. That's why it isn't any power also. It should be. I can open another one. I'll close this one. File, display, samples. Let's take my TZR, and let's take the last YouTube special from that one that we used in part 2. And let's look at the waves right here, and expansion and pressure. Now you can see. Let's do it a little bit faster. This is the pressure. Piston goes down, and bam, up against 2.4. This is 1.4 bar. Absolute bar is 2.4. And you can follow the waves, how it now it's returning here. When there might be some optimization still left to do in this one. But this will be it for part 3. And the dog's alarmed again, always. That's how I finish my videos. Well, thank you. I'll see you in part 4. Bye.